Welcome to today's lesson on significant figures. The learning target is I can identify which digits are significant. So our first question is, what is a significant figure? A significant figure is also sometimes called a significant digit, and those digits, perhaps this 3 within this larger number, is going to give meaning to a measurement. It is not simply a placeholder. So if we were to look at these two numbers, for instance, here we're looking at 0.0035 grams, or I maybe read that wrong. Regardless, this is grams. It's a balance. Let's say that this balance is, I don't know, it's measuring something in a lab, and it has the ability to measure out 5 decimal places. This turned out to be zeros, so in terms of significant digits, you'll know by the end of this that this number only has 2 significant digits, just the 3 and the 5, but it has the ability to give you at least 5 significant digits here. So that would be a scale with very high precision. This is something you're only going to find in a very good chemistry lab, and the scale probably costs a few $1,000s. Going out 5 decimal places takes a lot of precision, and that has to be a very well-kept balance. Now, on the other hand, we're looking at this balance, which has very low precision. This is probably my kitchen scale. My kitchen scale only measures to the ones place, just like this scale is doing. So what this means is that if I put something on the scale that was less than a gram, let's say it's 0.2 grams. If it were 0.2 grams and it's measuring to the ones place, my scale would read it as 0, or my scale would tell me that it's 0. If I put it on the scale and it's 0.5 grams, then the scale is going to round up that measurement to the ones place. If it were 0.6, it would round to the ones place. 0.7, it would round to 1. 0.8, it would round to 1. 0.9, it would round to 1. I'm sure you're getting this. From 0.5 all the way up to 1.49, my scale is going to tell me 1 gram. That is because it's a $15 scale. It's very low precision. It only measures to the ones place. So the number of digits that we're given is essentially going to give us a clue as to how they were obtained. So this scale has an ability to go out 5 decimal places and could have given us 1, 2, 3, 4, 5 significant figures, where this one is just giving us 1. So this is a high quality instrument, a high precision instrument. This is a very low quality, low precision instrument. Now, I don't need this kind of precision in my kitchen. Very few people do. So it's just what you need in a given environment. Not even all chemistry labs need something this crazy. This is going to be like some sort of quantitative analysis lab that's going out 5 decimal places, something possibly working in nanotechnology. Okay, so 0 is just a placeholder. It's crazy to think about, but 0 is a digit that has no value. Scientists have made rules about which zeros are important to a measurement and when they're acting as placeholders, because sometimes it's hard to tell. Here are all of those rules. And this is the rules for significant figures. The reason we have all of these rules is because we need to determine when we're writing lab reports how precise these measurements are that people are reporting. If you are trying to read a lab report and they're giving you digits with numbers with low precision, you are not necessarily going to get the same numbers as them because of the rounding issues. Something with high precision, you know that they're working in a super high-tech lab, and if you're not, you are going to wind up with lower precision numbers. When we're trying to figure out which digits are important to measurements, we follow these rules. So all of our non-zero numbers are significant. They give meaning to their measurements. If I told you I was 5 feet 6 inches tall, that means that I am 5 feet 6 inches tall. If I told you that I was 5 foot 0 inches tall, that 0 inches is not important because I'm just 5 feet tall. That's essentially the difference between significant digits and insignificant digits. Everything that is 1 through 9 definitely counts. It's giving real meaning to a measurement. Now, leading zeros are these two zeros here, zeros that come in front of other numbers. Those zeros are not significant. Those count as placeholders. And all they're doing is pushing this 5 and 6 further back so that they can go into the tenths and the hundredths place. No, not the tenths. That's the hundredths and the thousandths place. Excuse me. Trailing zeros are the ones that come behind other digits. So in this case, these zeros behind the 5 and 500 are just pushing the 5 up into the hundreds place. If I had a decimal behind this 500, this would mean it's exactly 500. And those zeros are telling you I have 0 tens, I have 0 ones, and they actually mean something in that case. So your trailing zeros are only significant if the number has a decimal. Then we have sandwich zeros, which are zeros between other numbers, and those always count. So in this case, I'm saying I have 8 hundreds, 0 tens, and 8 ones. Those 0 tens are important. Now, I am a huge proponent for learning the tricks. So here's the trick so that you don't have to remember all of these rules, because sometimes these rules overlap, and inside a number, you'll have trailing and leading and sandwich zeros. So it gets a little bit confusing. Here's the trick. Imagine that this horrible doodle looks like a map of America, okay? If this were America, then the ocean over here would be the Atlantic, and this one would be the Pacific. This present and absent refers to if the decimal is written or not, okay? So if my decimal is written, it's saying, hey, this is the exact number. If my decimal is missing, it says, hey, we're kind of close to this number. We may have rounded to this number. Okay. So here we are looking at 785. 785, my decimal is absent. I am going to start counting from the Atlantic side of the number. So I'm coming in here. And the first thing I'm going to do is start counting at my first non zero number. 5 is my first non zero number. So I'm going to count the 5, and I'm going to count everything that comes after it in the Atlantic direction. Are you seeing the pointer? I start at the 5, and I count everything that comes after it in the Atlantic direction. So I would count the 5, the 8, and the 7. That gives me 3 significant figures. And if you remember from the rules, all non-zero numbers are significant. So that's 1, 2, 3 zeros are, 1, 2, 3 digits are not zero. They have to count. That means all 3 of them are considered significant. We sometimes like to call them sig figs just because it's cute. It's like shorthand. It's something that scientists understand and the other people don't. You know, it's just one of our things that we like to do. So here's a new number. 0.0058. Question. Are these zeros placeholders, or do they have real value? So we are looking at this inside a map of America, and my decimal is present. It's right here. It has been written. So that means that this number is exactly 0.0058. My decimal is present. I'm going to start counting from the Pacific side. I'm going to go in, and I'm going to look for my first non-zero number, which is 5. I count the 5 and everything that comes after it, no matter what. So I'm counting the 5 and the 8. That gives me 2 sig figs. Next is 500. 500, my decimal is absent, so I'm going to start counting from the Atlantic side of the number. I'm going in. I'm looking for my first non-zero number, which happens to be the 5. I'm counting the 5 and everything that comes after it in the Atlantic direction. All I have here is this 5. So it's just the 5. I have one significant figure. This means that the number somehow was rounded to 500. This would be considered a low precision number. Next, we have 500 with a decimal. This decimal is saying, hey, it's exactly 500. So our decimal is present. We're coming in at the Pacific side. We start at the 5 because that's our first non-zero number. and we count everything that comes after it no matter what. So we're counting 5, 0, 0. That is giving us 3 significant figures. Now, I know in math class, they say, oh, the decimal is optional. There is a major difference in science between 500 and 500 decimal point. This means I had a number and it rounded to 500. This means it was exactly 500. That's really what sig figs are for, to tell you how good of a measurement we have. Okay. Last one, we have some leading zeros, we have a sandwiched zero, and we have a trailing zero. How many of these digits are significant? This is where I like the Pacific Atlantic rule better than the list of the rules, because this will always work every time, no matter what. So my decimal is present. It's written right here. So I'm going to start counting from the Pacific side of the number. I'm going to look for my first non-zero number. So I'm skipping these first 2 zeros. Then I'm counting everything, this 5 and everything that comes after it in the Pacific direction. So that gives me 1, 2, 3, 4, 5 significant digits. What this is basically saying is that these zeros are working to push all of these into their correct places. And this 0 could have been a number 1 through 9, and this 0 could have been a number 1 through 9 if this measurement was just a little bit bigger. So that is why this has 5 significant figures. That's everything I have for you. If you're a little bit confused, it's okay. This is one of those things that you just get with practice. You'll get more practice in class. I suggest, if you're confused, to go back to the beginning and rewatch